Hello, everybody. Hope you have studied ISTQB Chapter 1 and went through all the Instagram videos for quick revision tips and the cheat sheets as well. So, here we'll be starting with a new chapter, that is Chapter 2, Testing Throughout the Software Development Life Cycle. We have heard about this word, right? SDLC in the Module 1. So, in this chapter, we will be diving deep into this module. We will be studying its models, test models, etc. So let's get started with the syllabus. So the syllabus of this chapter is divided into three parts: 2.1, 2.2, and 2.3. So 2.1 is about testing in the context of software development lifecycle. In this video, we'll be covering 2.1. In 2.1, there are 6 modules or submodules, out of which 5 are K2 and out of which 4 are K2 and 2 are K1. So K2, as I said at the earlier modules or chapters, K2 means you have to understand, you should be able to explain, and also you should be able to relate it to real world examples. Whereas K1 is just recalling the definitions or remembering the facts. K3 is the hardest part, where you have to apply the knowledge, just like you'll be getting some real case scenarios, and then you have to answer on basis of those scenarios. Okay, so let's get started. First submodule is impact of chosen software development lifecycle on testing. In this, we'll be covering up what are the different models, SDLC models, and on what situations we'll be choosing which model. Second one is K1, where you have to just recall good testing practices. Some of the testing practices we have already covered in the module chapter 1, so it won't be that difficult. K1 is to recall the examples of test first approach to development. Do you remember shift left or early testing principle? So it relates to exactly the same but in detail. So then we have K2, summarize how DevOps will impact on testing. So this is a new part, DevOps. We will be covering that. Then we have explain shift left, nothing but the early testing principle. And then you have explain how retrospectives can be used on mechanism to process improvement. So the IT professionals who are experienced testers might already relate to this word retrospectives, right? We have retrospective meetings going on in our organizations. So let's understand what are those for. So this is K2. So let's get started with our very first. So very first submodule is testing in context of SDLC. So what is an SDLC model? It is basically a high level representation of your entire testing cycle. So there will be, we just saw that there will be different testing activities in the last module, that was module 1.4. So basically it will be an high level representation of the sequence of those testing activities with respect to development activities as well. So yeah, testing activities performed within the process, how development phases and the testing phases relate to each other, that is explained in this module. So there are several test driven development. So first you decide what type of testing you want, and then based on that you decide the development. So there are several examples, we'll be going through them one by one. So that is acceptance test driven, behavior driven, domain driven. Okay, these we will not be covering, but just so you know that this also are used in some of the corporates. Extreme programming, feature driven development, Kanban and Scrum, we will be able to study it in the next part of ISTQBs, and it is very helpful. It is used in all worldwide organizations. Okay, so let's get started with 2.1.1, that is impact of SDLC on the testing. So testing must be adapted to SDLC to succeed. What it means that basically testing phases should be aligned to the development phases. Development phases should be designed keeping testing perspective in mind. So it is, in other words, it is saying that what are your expectations after the development of a particular module should be clear, and based on that the development will be carried out. So the choice of SDLC model, it depends on scope and timing of test activities like test levels and test types. Then it will be choice of test techniques and test approach, that also we saw. what are the test techniques, what are the test approach, and we'll be seeing them in details. Levels of detail of test documentation, to what extent do you want to document the test process. Extent of test automation, to what level you want to automate or automate the coverage. Then you have roles and responsibilities of tester, like to what extent a tester will test, that is nothing but independence of testing, that we already saw. And to what level developers or the authors of the code will test. Okay, so the first model, basically in this module we'll be studying three generalized models which are used from the very start. So the first one is sequential model. In this model, development activities happen in a prescribed sequence. Complete system is developed in a linear way of several discrete and successive phases. So all the phases are basically successive to in nature. So the, let's say phase number 2 is built on phase number 1, phase number 3 is built on phase number 2. So the development has been carried on in a linear way. Now there are advantages and disadvantages of the same. Waterfall model is one of the sequential models, and the earliest model, which is very popular, even you might have heard this word. Testing tends to happen towards the end of life cycle, because since the development itself is not complete till the end, testing is always preferred at the end of life cycle. And due to this shift left approach, implementation in this kind of model is very difficult. So early testing approach fails, or the principle fails in this kind of models. However, testers are involved in the static analysis in initial phases. Okay, for the test review, test analysis, test design. But the executable code is ready only at the end of the cycle, since it is linear in nature. So dynamic testing happens at the extreme end of the development. That is the disadvantage of this model. And what will happen as a consequence of this is that the cost of the project will increase towards the end, as several defects may chain till the end of the testing. So if you find out critical defects, and you will, of course, if you are doing testing at the end of the cycle, then the cost of the project might increase, and there will be a lot of rework, and the debugging procedure will also be very hard for the developers to debug which component or what is the root cause analysis of the failures. So it is not advisable to use this model recently, but I have made a simple diagram to understand the entire module 2.1 in a glance. So we saw that the development cycles are developed or designed as per testing approaches, right? So this is how they do it. The first one is deciding the intention of the product or the process. Okay, so that is wish, policy, laws, etc. Everything you will decide at the start. Then as per that you will form the user requirements. Now if you see in the left side is aligning with the right side. Based on the user requirements, acceptance test criteria will be prepared. Okay, acceptance is nothing but prepared by from the users or business representative, to check if the meet the intention of the product or process is met at the end, which is nothing but validation. Then after user requirements, we design system requirements. Accordingly, system test is prepared and then executed. Then you have global design, where you prepare integration test, and then integration test is executed. Then you have detailed design. Okay, now after detailed design you come to implementation. So in this V model you saw that how development is getting built to, till until the very end of this, and it is only after the implementation you can start the. So this is nothing but development. Okay, this is nothing but development, and this is nothing but testing. From here all the testing part will start up till the end. Okay, by testing I mean dynamic testing. Okay, and this is nothing but I have tried to relate the development phases to the testing phases. Okay, so this is the V model that we call. Hope you understood sequential model. Now next move to the next. The next one is iterative and incremental models. So it is assumed that each iteration delivers a working prototype. So you imagine how amazing this is. You will be designing the product or a process into iterations, okay, and the end of iteration will deliver a working prototype, and you will kind of build on the working prototypes. You will make it more enhanced in features going forward, but at the end of every iteration you will be having a deliverable working prototype to the customer, so that you get feedback very fast from the customer. And uh, at the same time, since you are getting the working prototype ready at the end of iteration cycle, testing becomes very easy to carry out from the very start itself. So it pretty much satisfies your early testing principle. So we will now dig deep into what is iterative and what is incremental. So it implies that at each iteration static and dynamic testing can be performed, okay. Frequent delivery of increments requires fast feedback and extensive regression testing. This part is very important. It requires extensive regression testing so that you know that whatever development you have carried out in the working prototype is not affecting the other working parts, okay. Now we will understand what is the difference between incremental and iterative. In incremental, you complete one piece at a time. Each increment may be delivered to the customer. So basically you are building upon one. Let's say there is one image. In that image you have delivered the first 10% of it, then in the first iteration, then in the second iteration you deliver the second 20% of it. Likewise, you will keep on completing that image horizontally. That is nothing but incremental model. An iterative model is basically you start with a rough product, refine it iteratively, as I said. So at the end of every iteration, you deliver a working prototype. Now, common issues with the iterative and incremental models is like they require more regression testing. So they need a separate team who carry out extensive regression testing defects outside the scope of iteration or increment. So since at the end of iteration it will be a working prototype, but they cannot log defects at that duration, because the working prototype is not entirely ready, okay. And the third one is less through testing. So it is kind of related to the defects part, that even if you do testing at the very early stage, then whatever defects you might get at the early stage, you won't be able to report it, or you have to keep them under observation until the prototype is deliverable. Actually it is deliverable from the first iteration itself, but until you are sure that the defect comes in the scope of actual functionality, or the working prototype is a minimum essential to log defects, okay. So agile software development, it assumes that change may occur throughout the project, okay. And agile is basically, the name itself suggests that it is being designed for handling dynamic changes or requirements of customers. Hence, lightweight work product documentation and extensive test automation to make are focused on. This is nothing but an iterative model, okay. And the same thing, that it is expected to do extensive automated regression testing. Most of the manual testing tends to be done out of experience based test testing that do not require extensive prior test analysis and design. Now we are going to study more about it in module 4.1, so let's not focus more on it now, but just keep in mind that agile is one example of iterative model. Then we have module 2.1.2. You have to just recall the good testing practices that apply to all software life development cycles. So for every SDLC activity, there is corresponding test activity that we saw in the V model that I had designed, right? Different test levels have specific test objectives which allow testing to be comprehensive while avoiding redundancy. Each and every test level should have a test objectives, or should be designed keeping the test objective or the goal in mind. Test analysis and test design for the given test level begins during the corresponding SDLC phase. For example, in the V model, I showed you that when the user requirement itself is ready, the business representative can start, designing the acceptance testing criteria based on the user requirement. Same goes for system testing. So the system testing criteria can be defined when the system design is completed. Okay, testers are involved for reviewing work products as soon as the drafts of work products are available. So it is nothing but shift left, which we are going to see further in detail at 2.1.5 module. Now the next part is testing as a driver of software development. Now tests are defined as a means for directing development. So first you decide what is the testing approach that you want to carry out, or what is the testing focus, and based on that you derive development life cycles. So TDD, ATDD, BDD are examples of test driven development. It implements early testing and allows them to focus on shift left. So as and when a work product is ready in the development cycle, you can immediately start with the testing. So this is the advantage of deriving development cycles from the testing approach. Okay, so test driven development, basically you have to direct coding through test cases instead of SW, software design. Tests are written first and then the code is written. So basically based on the user expectation or based from the validation perspective, test cases are written first, and based on those test cases or to satisfy the test criteria, you are writing the code or developing the code. So that is test driven development. Acceptance test driven development derives test from acceptance criteria. So first you define the user requirement. From that user requirement you get the acceptance criteria, and as per the acceptance criteria or to satisfy it, you're writing the course. Tests are written before the part of application is developed to satisfy the test. It is a very helpful approach. Going on to the next one, behavior driven development expresses the desired behavior of application with test cases written in simple natural language which is easy to understand by stakeholders. So I had explained earlier also that stakeholders don't understand technical terms. You have to put it everything in layman terms that they can understand, or in a simple natural language about what the behavior of object will be, how it will perform, etc. So this has to be in a simple natural language. So test cases should then be automatically translated into executable tests. Okay, so this also comes as a part of validation, behavior driven development. Okay, for all the above approaches, test must persist as automated tests to ensure code quality in future adaptations. So in test driven development, TDD, acceptance driven development, ATDD, and behavior driven development, BDD, it should be automated to the extent as possible, so that it is very easy to ensure the code quality in future adaptations. Now you have module 2.1.4, summarize how DevOps might have impact on testing. As the name itself impacts, DevOps is an organizational approach. It is complete organization shift where development and operations, they the teams performs cross functionally or together. Okay, it requires a cultural shift in organization to bridge the gap between development. It also includes testing, by the way, and operations. So DevOps promotes team economy, fast feedback, and integrated tool chains and technical practices like CI/CD, continuous integration, continuous delivery. This enables team to build, test, and release code faster through DevOps. So basically, since the development and operations team work together, or they are nothing but a single team, including testing, they will be able to build the code. Building the code means, let's say you have some defects were logged in the previous cycle. Okay, now those defects are getting fixed, or they are supposed to fix this defect in a code. Now development team will fix the defect in the code, and the operations team will merge the changes together into a build, and then you after the build is ready they will release it. So now that is possible when development and operations team work together, and DevOps delivery pipeline has made it very easy for them to build, test, and release code. From testing perspective, some of the benefits are fast feedback on code quality, and you can start the regression testings right away. CI promotes shift left in testing by encouraging developers to submit high quality code accompanied by component tests and static analysis. So basically the more faster you build the defects you have fixed in the previous code, the more fast the testing will happen, and that will exactly like contribute to more success towards the project. That is basically implementing the early testing principle. So that's why DevOps is an important part. The visibility of non-functional quality characteristics increases, that is performance, efficiency, reliability. Non-functional means performance or load testing, where you don't focus on the functional aspects. What is functional aspect? Basically, this is the input, this should be the behavior, or this should be the output. But performance is like, if there is any lag in the performance of the product, or when you try to bring more load on the system, is it behaving differently than expected? That is the non-functional aspect of it. So automation through delivery pipeline reduces the need for repetitive manual testing. So DevOps has made it very easy for the automation to, for end-to-end automation basically, where they will be integrating the defect fixes or some new feature releases in the code, in the build. They will be building it, they will be testing the build, and then they will be releasing it to the testing team again. DevOps challenges. This delivery pipeline must be defined and established. So it is a one-time thing that you have to define based on the test approach or development approach, that what is the structure of the DevOps pipeline, at what point you will be integrating the CI/CD pipeline. Okay, how many servers will be connected, how many systems will be connected, etc. CI/CD tools must be introduced and maintained. Test automation requires additional resources and may be difficult to maintain and establish. So this entire thing assumes that everything is automated. So for automation you obviously need more resources, but believe me, once you have established this, it becomes very useful, and it delivers more success. Okay, now the part that we have studied before is shift left. Shift left is principle of early testing. We saw it module 1.3. Testing should be done as early as possible to reduce the cost or to reduce fixing defects at the last moment. So reviewing the specification, so this practices actually helps to achieve shift left. The more sooner you involve the testers in the activities, the more they will be aware and they can start testing right away. So they should be involved in reviewing the specification, they should be involved in reviewing the code design, the system design, okay, the global design, writing test cases before code is written, and having a code run in the test harness. So this we discussed, right? Test driven development. Then using CI/CD as it comes with a fast feedback and automated component tests to accompany source code. So all of these things that we have studied before, test driven developments, choosing a right SDLC model, like iterative or incremental model, we also saw an example of it using CI/CD. So this shift left is achieved basically on implementation of all of these submodules from 2.1.1 to 2.1.4. Okay, completing the static analysis of source code prior to dynamic analysis. So the more deeply you perform static analysis, the more you know the product, and it is easy to explore defects out of it. Then you have to also perform non-functional testing. Okay, this can be also possible by CI/CD. Then shift left might result in extra training or effort. That is fine, but it is a one time thing, and I believe that shift left approach should be implemented. It is important to convince stakeholders to bring shift left concept to implementation. Actually, you have to keep stakeholders in the loop, because since it requires more training and more time investment at the start, where you will be involving testers right away from the start. So that will require an alignment with the stakeholders on the basis of budget or resource allocation, etc. But once it is built and established, it is going to be very useful. Now comes the last part of it, 2.1.6, that is retrospectives and process improvement. What are retrospectives? They are conducted at the end of any iteration or project cycle. So retrospectives is basically what went well throughout the process, what went wrong, and if something went wrong, what was the learning out of it or how to fix it, and you document it into learning documents. Okay, and what can be done further. So basically what went wrong is divided into action items, and those action items will be implemented in the next iteration cycle. That is nothing but a retrospective. So it has three components: what was successful, what was not successful and could be improved, how to incorporate improvements and retain success in future. That is nothing but deriving action items for next iteration. Okay, AI, action items. Okay, the results of the recorded in are normally a part of test completion report. We saw the text completion activity. So retrospectives are basically a part of that activity. Retrospectives are critical for successful implementation of continuous improvement, and it is very important that the action items are being followed up in the next iteration cycles. Typical benefits of testing: increased test effectiveness or efficiency, quality of test wear, team bonding and learning, improved quality of test basis, okay, and better cooperation between development and testing. Collab is reviewed and optimized regularly. So the more early you bring testing to implementation, you are avoiding the conflicts between testers and developers, because testers also have the knowledge of the product now. Okay, so they will be able to find actual defects, not invalid defects based on some presumptions. Okay, so this marks the end of module 2.1, and I have prepared some few slides that will kind of summarize this, because it was a huge module. It had six sub modules. So the first one, we saw that impact of SDLC on testing, some good testing practices, test first approach, that is shift left approach. Okay, SDLC we saw. What is XDLC? We saw sequential, iterative, and incremental models. Okay, waterfall and agile respectively. Then we saw what was the impact of SDLC. It is basically it is based on the scope, timing, techniques, the extent of automation, the extent of test documentation, or the roles of testers, roles and responsibilities. Now testing in modules, basically in sequential module it is late testing, iterative it is continuous testing, and agile is a part of iterative. Okay, now test activity for every the good testing practices is basically we saw the V model, right? There was a test activity corresponding to every development activity, and the development cycle itself is driven from the test, keeping the test approach in mind. So we saw TDD, ATDD and VDD on the criteria, right? Okay, so first you design test cases, and based on that the code is written. In this, based on the acceptance criteria, that is validation criteria, the code is written. And in this, given when then, so basically behavior, when this input is given, this output will be derived. That is behavior driven development. Then you have DevOps and testing. Okay, you have CI/CD pipeline. The codes can be built together when development and operation teams, and in development team, testing team also works. All of these three teams work together. So you can automate the component testing, and the more sooner you automate it, you receive faster feedback from customers. The more sooner you can integrate the fixes, and it reduces the cost extensively at the end of the project. Then we have a shift left approach, which we saw in the previous module also. You test early in SDLC, review early, test design, and CI/CD. With the help of CI/CD, you will be able to perform rigorous automated extension, automated regression testing. Okay, then we saw retrospectives, in which we discuss what was successful, what was not successful. If not successful, what were the improvement points, and we enhance collaboration. We keep track of those improvement points and how they are getting implemented in the next iteration cycles. So this marks end of module 2.1. If you have any doubts, feel free to post them in the community, and also refer to Instagram videos. Since this module is big, I'll be posting 3 videos for the same. Okay, and then at the end I will be giving you a cheat sheet on LinkedIn, so make sure you stay active on LinkedIn as well. Thank you so much.